Hello folks, in this video we're going to talk a little bit more about the impulse-momentum connection, more specifically the effect on force and time and how they're related. And we're also going to dive into a little bit about rebounding and the effect that rebounding has on collisions. We are also going to talk just a little bit about the different units of impulse. And you'll see two different units and why that's the case. So as I was talking about in the end of the last video, the collision time and force are very closely related. And there's some really amazing real-world applications about this particular physics concept. So combinations, remember force and time. Force is measured in newtons, time is measured in seconds, and impulse is measured in newton seconds. Remember, impulse is force multiplied by the time the force is applied. And so, if I have 100 newtons of force applied for 1 second, I have an impulse of 100 newton seconds. And these are all different force-time combinations that add up to 100 or multiply to 100 newton seconds. If I have 25 newtons of force, it takes 4 seconds of that force being applied to get an impulse of 100 newton seconds. And then a force of 1 newton, it would take 100 seconds to get an impulse of 100 newton seconds. And the implications of this are that if we have a big time and the same amount of momentum change, we have a little force. If we have the same momentum change and a really short time, we'll have a big force. And so this has a really big impact on, see what I did there? Impact on car crashes and collisions. Because typically we're going from a high speed to a stop. And so if I have padding that lengthens the time of the collision, I will greatly reduce the force of that impact. So some real world examples, and I'll post a video of this, and you probably saw in the car crash video some great examples of this, but pads in the gym or around basketball poles, right? If you crash into those lengthen the time of impact, reducing the force. Same thing with boxing gloves, the padded boxing gloves, and boxers, when they get hit really hard in the face, a lot of times what they'll do is they'll relax their neck and they'll do what's called riding the punch, which basically they allow their head to just move backwards with the punch, and they take the force over a bigger amount of time, and what actually it does is it reduces the force that they actually feel on their face, and allows them to stay in the ring longer, because if they're getting hit less hard, they're going to be able to stand up longer and stay in the ring longer. How about catching water balloons? How many of y'all have done a water balloon toss, right? Maybe some of you haven't, but if I try and catch a balloon full of water, I'm not going to just quickly catch that water balloon. When that water balloon comes towards me, I'm going to cradle it down and guide it slowly to a stop. And what that's doing is it's lengthening the time of that collision, greatly reducing the force, and therefore allowing the water balloon not to pop. If you all drive on highways or expressways and there's those big concrete barriers in the middle of the road, oftentimes you'll see these big yellow barrels with black tops or yellow tops and they're painted stripe. Those are actually full of water. And what those are designed to do is if a car crashes into a concrete barrier that's unprotected, that impact is going to be really hard and really fast, and it's going to be catastrophic for the driver of that vehicle. However, with those big barrels, what they do is they slow the car down over a greater amount of time, greatly reducing the force and chances for survival in that car crash. Rock climbing ropes. The rock climbing ropes are made out of nylon, and they're designed to stretch or elongate when a climber falls. And so what that does, imagine falling onto a steel cable. It's going to stop you really quickly, maybe break your back. Really bad stuff is going to happen. But if you have a really stretchy rope, your fall stops more slowly and it reduces the force of the impact. Another example. How am I going to land if I jump off this table? Am I going to land with my knees completely straight? Absolutely not. That hurt a lot, right? And so what I'm going to do is when I jump, I'm going to bend down and flex my knees, and that's going to absorb some of that force, lengthening the time of the collision, therefore causing less force on my knees. So going back to impulse, the units of impulse are Newton seconds. It's force multiplied by time. But some of you may be like, well, you told us impulse is equal to our change in momentum. And momentum is kilograms meters over seconds. How can they be two different things? Well, a Newton second is actually a kilogram meter per second. And the reason a Newton is a kilogram meter over second squared. If I multiply a Newton, this unit, by seconds, one of those seconds cancels out and I'm just left with a kilogram meter over second. All right. Last thing I want to talk to you all about. Rebounding. So a rebounding effect. So I get two situations. One, this ball hits a wall and bounces back. My velocity change is 9 meters per second. I have a -4 here, +5 here, and I actually have a change of -9 meters per second. Versus this, I have a change in my velocity, 0 meters per second, 5 meters per second. We just come to a stop. I have a change of -5 meters per second. If I have a bigger change in velocity, I have a bigger change in momentum, which gives me a bigger impulse, more force. And again, this is another reason that cars are designed to crumple on impact, is because we don't want our cars firm and then they just bounce